Welcome to Section 8.3, Part 3. This is the 67th session of the CISSP exam prep series. This part completes our tour of the classic security models. In this session, we'll finish the model family and clear up a word that trips people up. We'll answer several questions. Why does Biba forbid reading down? What are Biba's known weaknesses? How does Clark-Wilson enforce integrity differently? How does the Brewer and Nash model handle conflicts of interest? And what does the word star actually mean across security topics? Why does this matter beyond the exam? Because integrity is not just about blocking outsiders, it is about not letting bad data poison good data. On the job, you constantly decide which sources are trustworthy enough to feed a validated system, and which commercial application should sit between a user and a database. These models give you the vocabulary to defend those design choices in an audit or a review. So why does Biba forbid reading down? The no write-up rule feels obvious, since you clearly do not want low-integrity data corrupting a high-integrity object. The read-down rule is the one that needs a moment. Think of integrity levels like the cleanliness of air. You would never pump air from a dusty workshop into a sterile clean room. In the same way, you never let unvalidated, lower integrity data flow up into a document you trust, because the risk of contamination is simply too high. That is why reading down is blocked. What are Biba's known weaknesses? It is a useful model, but it has real limits worth remembering. It addresses only integrity, ignoring confidentiality and availability entirely. It focuses on external threats and simply assumes internal threats are handled elsewhere in the code. It does not manage access control, and it offers no way to assign or change the classification of a subject or object. And like several of its peers, it does nothing to stop covert channels. Think of a lock that secures your front door beautifully, but leaves the windows completely unaddressed. It is strong at one job and silent on the rest. How does Clark-Wilson enforce integrity differently? Instead of a formal state machine, Clark-Wilson protects integrity through a three-part relationship: the access control triplet of subject, program, and object. The key idea is that subjects never touch objects directly. They must go through a well-formed transaction, a control program that limits exactly what can be done. Protected data is a constrained data item. Unvalidated data is unconstrained. A verification procedure confirms integrity, and only transformation procedures may modify protected data. That constrained interface, plus separation of duties, is what keeps data trustworthy, which is why this model is so popular in commercial applications. Think of a bank teller window. You never reach into the vault yourself. You make your request through the teller, who is only allowed to perform specific approved actions. How does the Brewer and Nash model handle conflicts of interest? This model changes a user's permissions dynamically based on what they have already accessed. It is designed to prevent conflicts of interest inside a shared dataset. Imagine a consultant who opens files for one client. The moment they do, the model automatically walls off access to any competing client's data in the same conflict class. Once that task is finished, their broad access returns. The whole point is to stop someone from sitting on both sides of a rivalry at once. You may hear this called the ethical wall model. Think of an accountant who, the instant they start auditing one supermarket chain, is locked out of a direct competitor's books until the job is done. What does the word star actually mean across security topics? Here the exam sets a small trap, because star shows up in several unrelated places. First, there is no formal model literally called the star model in security, despite how it sounds. What does exist is the star property, the right rule inside both Bell Lapadula and Biba that we have already covered. Separately, a well-known cloud alliance runs a program abbreviated STAR that focuses on assessing cloud provider security through auditing and transparency, which has nothing to do with read and write rules. And in business management, there is an entirely unrelated organizational design framework that also uses the word STAR. Think of a common word like spring, which means a coil, a season, and a water source depending on context. Read carefully and let the surrounding words tell you which star is meant. So let's bring it together. Biba blocks reading down to keep low integrity data from contaminating trusted data. though it covers only integrity and ignores covert channels. Clark Wilson protects integrity through the subject-program-object triplet, forcing all access through controlled transactions. Brewer and Nash dynamically walls off conflicting data to prevent conflicts of interest. And the word star means different things in different places, so context is everything. With these models in hand, you can read almost any model question and know exactly what it is testing. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.